Today's journey through the bleeding edge of 1970s home computing is brought to you by Squarespace. But more on that in a bit. In our previous video on this beautiful and rare 1976 Sol 20, the earliest of the original home micros, we took it apart, fixed some of its issues, cleaned it up a bit, and explored its history. Well, today we're going to do what we love to do on this channel. Power it up, figure out how to load software on it from the internet, and see what this 47-year-old 2 MHz 8080 powerhouse is capable of. So stay tuned. And if you enjoy harkening back to a simpler time where killer new computer features included such innovations as screen and keyboard, I hope you'll consider subscribing to the channel. So we're back today with our Sol 20 with all of its glorious steel and walnut. If you want to know more about this wonderful thing's history, check out the previous video right here. But today, we're going to focus on my favorite thing, trying to actually use the machine. It still has some issues though. I did finish rebuilding the keyboard with those brand new Tech-Select foam and foil pads, and it works almost completely, but it didn't turn out perfectly. We'll take a look at what I had to do in a bit and tweak a few of the pads, hopefully for the last time. But the main thing that I want to do today is try and load some software on here, because as obscure as this Sol 20 is, there's actually a pretty dedicated community around it. Right at the center of which is sol20.org from Jim Battle, a gargantuan repository of manuals, articles, hardware info, and pretty much all of the Sol 20 specific software known to exist. So we have a pretty wide range of titles that hopefully we'll be able to check out. But first, let me show you what I did to the keyboard, because we need to tweak it a little bit, and yeah, hopefully this time we'll get it 100%. So the problem that I've been having is, even though I've replaced all of these foam pads with these Tech-Select pads, some of these are slightly different heights than others. And yeah, what wound up happening is that most of the keys would work, but some of the keys just wouldn't make good contact. And I tried a bunch of stuff, including sanding down the capacitive pads, but what wound up working was actually splitting apart some of these pads and just using the little bit of plastic as a tiny spacer. And now all of the keys work, except the return key isn't reliable. I think I need to add a spacer to it. And some of these keys just feel a little harder to press down than others. You can kind of hear it. So I want to just tweak it. Every time I take it apart, inside and out, everything about this machine is beautiful. So here are the famous foam and foil switches. And oh, I almost forgot the most important thing. I found these Gorilla adhesive dots and used these to stick the foam and foil to the underside of the kind of plastic key switch little connector thing. And it looks like for the most part they have stayed in place. So I'm just going to use some tweezers and stick these all back down so they're straight. And then I'll add a little bit of a spacer to the return key, and then we'll put it back together. So it's actually surprisingly simple to load software onto this thing with a modern computer. All you need is a serial cable, or in our case, a USB to serial adapter. And the Sol's operating system actually has a built-in command that makes this honestly shockingly simple, at least in principle. So let's hop on to sol20.org, pick out a couple of titles from the software library, and then get these two machines configured to talk to one another. right after this word about today's sponsor, Squarespace. Create a fast, beautiful, and rich web experience for your business or brand using Squarespace's powerful all-in-one platform. It's really easy to get started. Like, say I wanted to build a website all about woodworking for the computer cases of the future. Not only could I build it in minutes with Squarespace, but I could do it without writing a single line of code. There's a ton of beautiful templates that I could choose to start from, and from there, it's simple to build a great looking site that's also fast, responsive, and works great on mobile devices. With Squarespace's extensive built-in toolset, I can also optimize for SEO, manage a mailing list, check my analytics, and much more, all geared towards managing your entire web presence. So check out squarespace.com/actionretro today for a free trial. And when you're ready to launch, use code ActionRetro to save 10% off your first purchase of a website or domain. So among the really cool features of the Sol 20 and Sol OS is the ability to redirect where input and output go. For example, in the Sol, input 1 is the serial port. So if I set the input to 1 with the command set I equals 1, the Sol will look for the next command to come from the serial port instead of from the keyboard. Which means that if we set the dip switch configuration on the Sol to match the terminal software on our modern computer like TerraTerm, we can just send text over serial, and the Sol will interpret that as if we typed it into the keyboard really fast. And combining this with some of the Sol's other commands, like the ability to type data directly into memory locations, we can use the modern computer to copy-paste giant text commands into the Sol. Like, for instance, a command which enters a full application directly into memory for us to then run. So I have the cover back off of here again because in order to configure this serial port, we actually need to configure these dip switches. And we're concerned with bank 3 here and bank 4. Bank 4 controls various settings in the serial port other than speed, and bank 3 controls the speed. So we can set it from 75 baud at the low end, which is basically typing very quickly with your fingers, all the way up to an astonishing 9600 baud. But I've read that people have the most success transferring stuff between 300 and 1200. So 300 will definitely work, and 1200 should work with some tweaks. Setting this to 6 will give us 1200 baud, and I'm going to start with that. If it doesn't work, we'll step it down to 600 and then 300. And then over on jumper 4, we have it set to 1 stop bit, so we'll leave everything at their defaults except for a stop bit turned on. And yeah, full duplex. And now we just have to configure the ThinkPad to do the same. On our ThinkPad, we'll be using some free open source software called TerraTerm, in addition to a USB to RS422, RS45 serial adapter, and a gender changer on the end, and an adapter to change it to DB25. As the computer clan would call it, a nice bit of conversion technology. So I'm just going to plug this into USB here. Make sure everything's working. It appears to be. And then we'll make sure TerraTerm can talk to it. Yep. Choose serial here. And COM6 USB serial port. And in here we can change our settings for the serial port to match TerraTerm. So we're starting at 1200. We have 1 stop bit, no parity. And then one trick I've heard is to add some delays here. So we'll do a delay for characters, but then the big thing is a delay after each line. So 100 milliseconds after each line goes through. All right, now we can finally try to talk to the Sol 20. Okay, so I didn't put the cover back on the Sol because we might need to play with the dip switches again to get this working. And yeah, I'm going to turn on the Soul and then enter into terminal to see if we can talk. All right, so on the Soul here, the first thing we're going to do is type TERM for terminal. And now that doesn't work. So when I type on the keyboard here, you can see that it's transmitting correctly. So there must be some configuration issue. I figured it out. Okay, let us go back into term. And now, anything I type on the ThinkPad shows up on the Soul. It was just this key right here, which in the previous video I said I had no idea what the local key did, but that needed to be turned off. Well now, oh there it goes. Yeah, that needed to be turned off. I should really read more in the documentation about how that works, but in practice, turned it off, and now data's going through. Okay, so I've set this for 2400 baud with that 100 millisecond delay after each new line, and it seems to be working. So here's how we're gonna do this. There is a paste feature here, and whatever we type in here, or better, copy and paste in here, will be transmitted to the Soul once we hit OK. Okay, so it did send the data through, but I don't think my little immature test there had the right line breaks. But fortunately, what we can do is take these ENT files and just open them up, and then I should just be able to Control-C this and paste it right on into TerraTerm here. Oh yeah, look at it go! Haha, that's awesome! Alright, fully loaded in, so it seems. Now we should be able to just type exec 4 zeros and load it. No, that's not right. Huh. Okay, so I think what's going on here is some bad RAM. Because when I do dump 0000 to 00FF, I get all Fs. And I don't think it should be that. I think it should be alternating rows of a couple rows of F and a couple rows of 0. So if you haven't seen Clyball's video, I'll link it up in the corner here. But basically how we're going to test these RAM chips is pretty simple. These 8 chips here, these are the system built-in memory. And then over here, these chips are the video memory. So when these video memory chips are working correctly, we'll see that 909090 pattern on the screen, even if there's no personality module installed. And I've taken the personality module out, so it will definitely not boot. If we were to remove one of these chips, or say one of them wasn't working, that pattern would change. So we are going to first pop one of these chips out and see the difference that it makes when we start it up with missing video memory. And then we're going to try each of these 8 RAM chips in the video memory position to see if one of them makes it work properly, or all of them make it work properly. But hopefully we'll find one of these that doesn't make a difference when we put it in this socket here, which will mean that RAM chip is defective. All right, well, all of the memory appears to be good. So it's not that. Okay, so it turns out that I somewhat misunderstood how the memory locations work in this machine. Memory location 0 is not the built-in memory here. And when I posted to the S100 group on Facebook, none other than Lee Felsenstein himself, one of the designers of this machine, responded. And, well, basically told me to go back and look in the manual. And it turns out the built-in RAM memory location is C800 to C8FF. So when I do dump C800 to C8FF, I have all zeros. And I think in the stock machine with no memory upgrade, that's all the user RAM we have to work with. So now if I enter some values at C800, like AA, BB, CC, and DD, and let's dump that memory and see if it actually got stored. It would help if I could type. There it is. AA, BB, CC, and DD. So in theory, if I have a program small enough that can fit in this memory, I should be able to transfer it over by adjusting the values to write the program to this part of memory. However, there's another option. I do have this 64K RAM expansion for S100 machines. It's actually a processor technology card. The only problem is when I tried this previously, well, 2 of these 40-something-year-old caps exploded. Now I have replaced them, and yeah, I had to do some other hacky stuff on here. There's supposed to be 2 blocks of configuration dip switches here to set where the memory goes in the system's memory map. And this one, for some reason, only had the 1 block of dip switches and then this kind of blank socket. So I don't know if maybe the dip switches broke and the previous owner put this in here instead. But what I've done to configure it is I've just made little jumpers out of the legs of components. And I put a little deoxit in there. And yeah, this should be configured to run 64K of memory in this machine, starting at memory location 0. The only thing is, I haven't tried it yet, and last time I tried this thing, 2 caps exploded. So, hey, let's see if we get some fireworks, huh? All right, here goes. Oh, thank God, no explosions. Something's weird. I'm getting strange characters. I feel like the memory card is having some weird effect on the machine. Okay, so I've gone through and really thoroughly cleaned this card. I removed all of the memory chips, sanded down the contacts, and then sprayed some deoxit in there before reseating everything, and it's all in there nice and firmly. I also rechecked these jumper settings, and I'm pretty sure they're correct. So let's try this thing again and see if we get memory at location 0. So enter at 0, A, B, and C. Now dump 0 through 30. Nope. Dagnabbit. Alright, I guess let's see if we can stick a program into the 1K of user memory. So I found here a very small program which is already written for starting at memory location C900. So let's try sending this over. All right, program transferred successfully. Nothing dropped out. So now just to check it, I'm going to dump location C900 through CADO. Yeah, looks like it's all there. So now we can do EX C900 and cross your fingers if we get some new software running. Blank screen. Hey! We have software from the internet in the tiny bit of RAM that we have available. And it's supposed to be a game, but maybe it's just a screensaver? Okay, actually looking at the notes for this program, it is supposed to be a game, and one of its selling points is that it is small enough to run entirely from the SRAM on the sole motherboard, which is exactly what we're trying to do to test this thing out. And we have to actually slow the system down with set S equals 80, S for speed, of course, or else it runs way too fast. And if I look at the screen, I do see something bouncing around extremely quickly. So let's reload this let's reload this program and slow the system down to 80% and see if we can play this game. Set S equals 80. Then EX C900. Look, there is something happening here. I think it's doing the game of life. All right, well, we did it. Although not quite to the level that I was hoping for, and with a lot more rigmarole than I anticipated at the start. Although I'm not going to edit that stuff out just to make this look easy, because sometimes these old machines can put up a fight. But I really think a big part of the fun is in the journey and in learning more about these systems, especially through trial and error and failure. And, well, we did figure out how to get software off of the internet and into this 47-year-old machine, and we successfully ran it, but we also learned a lot about how the memory works on this machine and how to address it, how to configure it, and we definitely learned that I need to get a working memory module to really explore the software on here that I want to, like Electric Pencil, and some of the really cool games that are available for this machine, and which are surprisingly fun to play despite this thing's limitations. There's even a brand new version of Tetris for it, written by someone who we've talked about on this channel before. So I think what I'm going to have to do is either find a new memory card for S100 machines, hopefully a processor technology one, or see if I can find someone maybe who can help me repair this one. But for now, if you enjoyed this video, I'd appreciate a thumbs up, and if you'd like to see more 47-year-old computer shenanigans, please subscribe down below, and thank you very much for watching. And a special thanks to Alex Hoffman, Camila Noceda, Chris Allegretta, Chris Biggs, Chris Calderon, Chris Nelson, Control-Alt-Reese, Daniel Hubbard, Greg from Hrutk Mods, Justin Hemmings, Justin Reed, Megahertz Models, Michael Mulhern, Paul Spencer, Ryan, Scott Thompson, Sutek, Tom Woodfin, and Unknown Soldier 41, who are my highest tiered patrons and all of my Patreon supporters who help to make these videos possible.